Hello everyone, we're on the last few questions now of this paper from November 2021, paper 2 for Edexcel. So question 19, it says we've got three spheres, A, B and C are three spheres. The volume of sphere A is 125 centimeters cubed. The volume of sphere B is 27 centimeters cubed. The ratio of the radius of spheres B to C is 1 to 2. Work out the ratio of the surface areas of the spheres A to sphere C. So in any question of this type, the key is to always find the linear scale factor, the area scale factor, and the volume scale factor. Now we can start off this question by finding they've given us the volume scale factor between A and B. And you'll notice that going from A to B is smaller. So in order to find the volume scale factor, we take the volume of B and divide it by the volume of A. And when we put that into our calculators, 27 over 125 turns out to be 3/5 cubed. Now that's really, really useful because we can cube root that to get our linear scale factor between A and B. So the linear scale factor to go from A to B is the cube root of 3/5, so it's just 3/5. And in turn, that means that the area scale factor, which is the linear scale factor squared, is going to be 3/5 squared. So now we know everything about going from A to B. We know the linear scale factor, the area scale factor, and the volume scale factor. Okay, that's great. Now let's park that result and let's now take the next piece of information. We're told that the ratio of the radius to go from B to C is 1 to 2. Now that is telling us our linear scale factor because a length is just a linear factor. So to go from B to C, it's a ratio of 1 to 2. Okay, that's fine. So therefore the area scale factor is going to be 1 squared and 2 squared, which is going to be 1 squared is 1 and 2 squared is 4. So 1 to 4 is the area scale factor. And then finally, the volume scale factor is going to be 1 to 2 cubed. So 1 cubed is 1 and 2 cubed is 8. So there's a volume scale factor of 1 to 8. So we can now bring these pieces of information together to work out the area scale factor that connects A and C. So let's write down, first of all, the area scale factor that connects A and B. So the area scale factor to go from A to B, if A is 1, is going to be 1 to 9 over 25. That's our area scale factor to go from A to B. Our area scale factor to go from B to C is 1 to 4. Now, in order to be able to combine these ratios to make a triple ratio like this, what we need to do is to times up this ratio so that this number matches our 9 over 25. Because if we can scale that up by multiplying both sides by some number, then we can write them as a direct comparison of the three ratios, okay? So what we need to do is, instead of thinking this as 1 to 4, we're going to multiply the 1 by 9 over 25 and the 4 by 9 over 25. And then when we do that, the ratio of B to C is in fact going to be 9 over 25 to 36 over 25 when we do that, okay? So we multiply them by 9 over 25, and we can now have a direct comparison. So we now have a ratio for surface area of 1 to 9 over 25 to 36 over 25. And the question's asking us for the surface area ratio that connects A and C. So if we just multiply all three parts of our ratio by 25, then that gives us a ratio of 25 to 9 to 36. So therefore the ratio of A to C is going to be 25 to 36. And that's how we would do question 19. Okay, question 20 rather, probability. Okay, here's a good one. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the following day is 0.6. The weather forecaster says that there is a 70% chance it's going to rain on Monday. Work out an estimate for the probability that it will rain in the village on Wednesday. You must show all of your working. So let's start at the beginning. So Monday, there's a 70% chance of rain on Monday. So there's a 30% chance it does not rain. So that's Monday taken care of. Tuesday, if it rains on Monday, if it rains on one day, the probability it will rain on the next is 0.8. So the probability of rain on Tuesday would be 0.8, and the probability of not rain would be 0.2. Let's turn our attention to what if it didn't rain on Monday? Well, if it didn't rain on Monday, if it does not rain on one day, the probability that it will rain on the next day is 0.6. So no rain on Monday means there's a 0.6 chance of rain on Tuesday and a 0.4 chance that it doesn't. So we've now dealt with all of the options for Monday and Tuesday, and we just need to work through and do the same now for Wednesday. So if it rained on Tuesday, then on Wednesday, we'd have 0.8 and 0.2 as our chances of rain. If it did not rain on Tuesday, we would have 0.6 and 0.4 as our chances of rain and not rain. Again, if it did rain on Tuesday, we would have 0.8 and 0.2, and if it did not rain on Tuesday, we'd have 0.6 and 0.4. And that completes our tree diagram. So we want to know the probability that it's going to be raining on Wednesday. So we have this option is rain on Wednesday, this option is rain on Wednesday, this is rain on Wednesday, and that one is also rain on Wednesday. So we need to work out their associated probabilities. So the probability from this branch is 0.7. Remember, we times along the branches. 0.7 times 0.8 times 0.8, which is 0.448. This branch is 0.7 times 0.2 times 0.6 along and down and up there. So that turns out to be 0.084. This branch is not rain, 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 0.3 times 0.6 times 0.8. And then finally, this branch here is not rain, rain, which is 0.3 times 0.4 times 0.6. So we now have all of these different ways it could be raining on Wednesday. It could be raining from this path, or from this path, or from this path, or from this path. So those are the four ways it could be raining. This way, or this way, or this way, or this way. Now, in probability, when you hear that word or, that means you have to add the probabilities. So when we add those four numbers together, that is our answer for the probability of rain on Wednesday, which is 0.748. Perfect. Well, we're now on the last question on the paper, the last grade 9 kind of question. And let's have a look at this very last question on this paper. So it says the time period in t seconds of a simple pendulum of length L is given by the formula t is equal to 2 pi times by the square root of L over G. Katie uses a simple pendulum in an experiment to find an estimate for the value of G. Here are her results. L equals 52.0, T equals 1.45, and they're both correct to 3 significant figures. Work out the upper and the lower bound for the value of G, using pi to be 3.142. You must show all of your working. Well, step 1, let's find our upper and lower bounds for L and T. So upper lower bound for L is, this is correct to 3 significant figures. So the upper bound is going to be 52.05, the lower bound is going to be 51.95. For T, our upper bound is going to be 1.455 and our lower bound is 1.445. So we've got our upper and lower bounds for L and T. Now this next step, again, I don't think is necessarily obvious, but we're going to rearrange this formula to make G the subject. In order to do that, we're going to do a number of steps. We're going to divide by 2 pi. We're then going to square both sides, so t squared over 4 pi squared. We're then going to, I would argue, we should take the reciprocal of both sides and then times by L. So actually here I could write an intermediate step. We could think of this as 4 pi squared over t squared equals G over L. And all we've done is take the reciprocal of both sides and put it equal to each other. So 4 pi squared over t squared is equal to G over L. Now all we need to do to make G the subject is just times those sides by L, and we end up here. So there's our formula for G. Now, in order to find the upper bound for a quotient, we need to have the smallest thing in the denominator. And the thing that helped me when I was learning this is when you divide by a smaller number, you get a bigger answer. So when you have a quotient like this, a fraction, and you want to get the biggest bound, you need to have the smallest on top and you need to have the biggest in the numerator. So that's how we're going to get an upper bound for a quotient like that. So we just put in the upper bound for the value of L, which is our 52.05. We put in the lower bound for our value of T, which was 1.445. Put that in, and that gives us our upper bound, which goes here. And then finally, our lower bound for G, we need to have the biggest thing in the denominator and the smallest thing in the numerator. So that means we're going to use the lower bound of L in the numerator, our 51.95, and we're going to use the upper bound for the time, the 1.455 in the denominator. We put all of that in and we find out our upper bound for G. And that is the answer for that question. Perfect. Well, I hope you found that helpful, that explanation to the last few questions on this paper, and I will see you all in the next video.